Today guys, we are going to do a decoder circuit, and what a decoder does, a decoder simply changes one information from one form to another, specifically for a decoder, it's used in computer circuits to change one form of information into another. So for me, let's take for example, if the computer, the computer doesn't read things as they are. It uses binary digits to communicate to different circuits and to implement the control function and everything. So for like number systems, if computer wants to read 1, it's going to take it as 0 1. If it wants to read 3, it's going to take it as 1 1. So this A and B is simply how a computer communicates to different circuits in it, different circuits in the processors and the memory and everything. So for you to be able to interpret that information, the computer has to turn that back into the normal state for humans to understand. To make it easy for humans to understand. So at this point, this input right here is we can take it as the inside of a computer, how it communicates. And once it wants to display its information to you as the user, it's going to take it through a decoder, which is going to convert that information maybe from binary into the form you're going to understand. So for mine, that's a simple one. It's going to convert binary into numbers, and that's basically what this 2 input 4 output decoder will be doing. So it's a simple circuit. It entails 2 input 1 output AND gates, 2 NOT gates, and I've used some various 4 LEDs just to show us what we are doing inside. So this, you can take it as a control. We are going to be controlling this part, and it's going to show us the numbers from 0 to 3. So yes, so for this first AND gate, you can see that the input are all negated. They are A and B, but they are all negated, meaning that the output, the Boolean expression of the AND gate number 1, we can write it as A bar dot B bar, or A complement, and A complement dot B complement. So that's going to give you 1 because of both of them are 0. For number 1, A is the one which is negated. A, we take A as negated, but B, yes, it is. So the Boolean expression is going to be A not A complement and B, just the way it is. That's the output of AND gate number 1. AND gate number 1. Then from there, AND gate number 2, which is going to show us 2. A is just the way it is, but B is complement, or B is 0. So A, it's going to be A just the way it is, dot B complement. That's going to give us 2. And it's going to light up this LED. Then our final AND gate number 3, all of the inputs are on. So A is taken as the way it is, and B is taken the way it is, and that's going to give you number 3. So basically that's how the circuit will be behaving. And it's just a simple circuit using an IC. So an IC, my IC has all of the four AND gates, and I'm also using an OR gate to make this circuit. Yes, and the LEDs you can use, the LEDs require some protection, so I'm using some 1 kilo ohm resistors to protect them against the currents of the circuit. So my circuit is right here, and you can see it's just a simple circuit. It uses very simple just a simple connection. The first integrated circuit here is just a NOT gate. The second integrated circuit is the AND gates, containing all the 4 AND gates. and my output side is here. So all of these are blue LEDs. This first one is going to show us 0, this second one is going to show us 1, that one is going to show us 2, and the final one is going to show us number 3. And my control or my input section is right here, containing A and B, which are orange LEDs, and I'm using the dip switch, those two switches, to turn these or to turn the circuit or to control which input I want to set. So that's basically what the circuit entails. And I'm using a 5-volt power supply. You can use any from 3 volts, but make sure you check the ratings of your integrated circuits to make sure that you don't damage them. So yes, that's basically what the circuit is. And yeah, let me power it and check, and it's on. So immediately you can see the first blue LED is on, and this first blue LED is used to show 0, that the input are at 0, 0 at A and 0 at B. That's why the output is 0. So this is 0. Yes. So if we want to make number 1, B has to be on and A has to be 0. So I'm going to put B on. B is this switch number 2. I put it on. Yes. Once I put it on, then it's going to show us number 1. Yes, this is number 1. So 0, number 1, because B is on. So binary 0, 1, 0, 1. It's giving us a 1. Yes. Then the next binary 1, 0. A is on, B is 0. So I'll turn this off. Then I put A on. Then 1, 0, 1, 0 will give us a 2. 2, yes. So 0, 1, 2. We are that LED which is showing us 2. So 1, 0, 1, 0 is 2. Then the final one, when all of the inputs are on, we should get a 3, this final LED. So I put B on. Then when all inputs are on, we get a 3. Yes. So that's basically what a decoder does. It changes the binary number systems into decimal number systems, or the normal number systems that we know. So you can take this as a computer side, which has the information in terms of binary. Then the decoder transforms it, and it displays you on the screen or somewhere else the numbers that you are able to interpret or to read. Yes, so this is a computer language, this is a human language. This is what you can understand, this is what the computer understands as 3, this is what you see as 3. Yes. So yes, so that's basically what the decoder circuit entails, just simple like that. And let us turn this off again. Let's do it again. So when all inputs are 0, we get a 0 output. 0 output, 0, it shows 0. When we want 1, B has to be on, A has to be 0. So B is on, we turn this on, then A 0. So 0, 1, 0, 1, we get a 1. Yes. Then the next one, when A is on and B is off. So we turn this off and we put number 1 on. That gives us 2. So we are from 0, 1, 2. So we are at 2. Yes, that's 2. Then number 3, all inputs has to be on. So I put this switch number 2 on. And when we get a 1, 1, it is 3. So 1, 1 binary is 3. Yes. So yes, that's basically what I wanted to show you, and what I wanted you to understand about the decoder circuit. So next time we are doing an encoder circuit. And yes, an encoder is just basically the opposite of a decoder. It transforms information from what we understand into what computer understands. So next time we are doing an encoder circuit, and the next time we are going to merge these circuits together and show you how information is turned from one form to another, then turned back into the original format. Yes, so thank you very much guys for watching. Please subscribe to Tronics Energy, where we do fun stuff all day, all the time. Yes.